Hopefully you've had a chance to do this problem. I'm going to walk through a solution now. And this is really focusing on practicing energy conversions using the conversions that I gave you in the previous lecture. And so this is a dimensional analysis problem. It's just applying it to non-metric units. So let's dive into it. The levelized cost of energy, and this doesn't include subsidies, for photovoltaic solar energy was 12.5 cents per kilowatt hour in 2015, the year I wrote this problem. I should update it. Now, this is compared to hydroelectric at the time, which was 8.4 cents per kilowatt hour. And so the question is, what is that difference in cost between photovoltaic energy and hydroelectric energy in terms of joules or calories? So let's start by just figuring out what that difference is in cents per kilowatt hour. So we've got our 12.5 cents per kilowatt hour. That's our photovoltaic energy. And we have for hydro 8.4 cents per kilowatt hour. So let's start with our 12.5 cents per kilowatt hour minus our 8.4 cents per kilowatt hour. That's going to give us 4.1 cents per kilowatt hour. And note that I am reporting to one decimal place here. Each of these has just one decimal place in the answer, and so for significant figures, I report to one decimal place because we're looking at addition and subtraction. All right, so now I have something that is an actual starting point to a conversion problem into joules or calories. So this 4.1 cents per kilowatt hour is my starting point. And this is different than a lot of the conversion problems we've already done. It's starting with a number that has units that incorporates 2 units within it. So we don't have just a single unit for our starting point. And now we need to convert this into joules, and then we need to do this into calories. And so let's start with joules. And if we want to look at this cost difference, we still need to keep that cents in our units. So we want to convert this number into something that is cents per joules. So to do a conversion like that, I know that I want to end up with joules actually on the bottom this time, right? Because I want it to be per joules. And I want my cents to stay on the top. So I'm not going to do anything to convert the unit of money being cents into anything else. And what I'm really going to focus on is getting rid of that unit of kilowatt hour and having it be joules. So if I multiply this by a conversion factor that is kilowatt hours on the top and joules on the bottom, these kilowatt hours will cancel and I'll have units of cents per joules. So this is kind of like reversed or flipped or inversed from what we were doing before. But it's using that same principle of our units are like variables, and we can set up our problem so our units cancel in a way that provide us the units that we're looking for. So now I can go ahead and plug in. I need a conversion for kilowatt hours to joules, which was given in the previous lecture. So I'll write it down here. 1 kilowatt hour is equal to 3.6 times 10 to the 6th joules. So I'll use that conversion in my problem. So I've got 1 kilowatt hour and 3.6 times 10 to the 6 joules. So plugging this into my calculator and dividing 4.1 by 3.6 times 10 to the 6, I'm going to get a value that is 1.14 times 10 to the negative 6 cents per joules. And now I'm going to have 3 significant figures in my answer that came out of my calculator, but I only have 2 sig figs right here in my starting point. So I'm going to report 2 significant figures at the end. Even if this 12.5 and 8.4 isn't a measured value, if maybe it's something that's like been measured so many times it's an exact number, I don't think so. So we'll treat it like an inexact number that was measured for a paper. So this will be 1.1 times 10 to the negative 6th cents per joules. All right, let's look at calories. So we can either start from our cents per joules and convert into calories, or we could start with our cents per kilowatt hours and convert that into calories. I think it's a little easier to start with joules because one of our conversion factors we have is that 1 calorie equals 4.184 joules. So my 1.1 times 10 to the negative 6 cents per joule will be multiplied by a conversion factor to get my into units that are cents per calorie. So I'm going to want calories on the bottom again, like I did joules previously. And I want to get rid of joules, which is on the bottom of my fraction starting. So I need to have it on the top of my conversion factor so they'll both cancel out. So I'm going to plug in my conversion factor here. I know that 4.184 joules will equal my 1 calorie. And looking at the way this is set up, only my units of joules cancel out, leaving cents per calories. Perfect. Plug it into my calculator. And I'm going to get a value that is 4.8 times 10 to the negative 6. I get 4.77, but I'm going to round to two significant figures. And that's how we solve this problem.